Okay, so long division of polynomials works just like a normal long division problem would with whole numbers, right? So I guess I will do just a really quick, I don't want to do that huge one up there, but just super, super quick. If I was to divide, I don't know, 1450 by 5, right? So you take your top number, or the number being divided, place it in your division house, and you take the number you're dividing by, the divisor, and you place it on the outside of your division house, and then you ask yourself, okay, does 5 fit into 1, our first digit? How many times can I multiply 5 by, or what can I multiply 5 by to get 1? Well, you can't. So then you have to go to the next digit. How many, or what can you multiply 5 by to equal 14? How many times does 5 fit into 14? It fits into 14 twice. Oh no. And then you multiply, then you have to multiply it back in. So 2 times 5 is 10. Then you subtract 14 minus 10 is 4, and you bring down the next term. And you ask yourself, okay, how many times does 45, or oh my God, how many times does 5 fit into 45? And you would say 9. And then you multiply the 9 to the 5 and you get 45. And then you subtract and you get 0, bring down the next term. How many times does 5 fit into 0? Well, you multiply 5 times 0 to get 0. That's kind of tricky, that concept there at the end. We won't have that actually when we're doing polynomial division. We won't ever end on a 0 like that. But yes, the answer to 1450 divided by 5 is 290. So same process here. We take what is being divided and we place it inside of our division house. And then we take what we're dividing by and place it on the outside. And then we ask ourselves, how many times, or what can I multiply 2x by to get 2x cubed? You always look at the first term here. So what do you multiply 2x by to get 2x cubed? What do you multiply 2x by to get 2x cubed? Yes, 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 yes. X squared. Yes. We multiply 2x by x squared to get 2x cubed. So then we have to multiply the x squared back into 2x. X squared times 2x is 2x cubed. Now, because we multiplied the first term, we also need to multiply the second term. X squared times 7 is 7x squared. Then, just like we did right here at this step, we need to subtract, but we need to subtract everything. So I like to place parentheses around my terms so that I know, okay, I'm having to subtract both of those terms. It's like a little reminder. 2x cubed minus 2x cancels out to 0. And 5x squared minus 7x squared is negative 2x squared. Then I have to bring down my next term, which is negative 19x. And then you repeat the process. Now it's just repetition. What do you multiply 2x by to get negative 2x squared? A little bit more. Negative x, yes. It needs to be a negative 2x squared, so you multiply it by negative x. Negative x times 2x is negative 2x squared. Then we also, because we multiplied by the first term, we also need to multiply by the second term. Negative x times 7 is negative 7x. Then we subtract everything. Negative 2x squared minus negative 2x squared is actually negative 2x squared plus 2x squared, so it cancels to 0. And negative 19x minus 7x is actually negative 19x plus 7x, which is negative 12x. And then we bring down our last term. What do we multiply 2x by to get negative 12x? Negative 6, yes. So then we multiply negative 6 times 2x and we get negative 12x. These should match, which they do. And then we multiply negative 6 times 7 and we get negative 42. And then we subtract everything. So we have negative 12x minus 12x cancels to 0. And negative 42 minus negative 42 also cancels to 0. And there is nothing else to bring down, so this would be my remainder, but it's a 0, so I don't have a remainder. So my answer to this question is x squared minus x minus 6. Which that does make sense because my leading term had been an x cubed. I divided out an x, so my leading term should be an x squared, which it is. Any questions so far on this long division? Okay, let's do one more, but I want one with a remainder. So we'll do that one, I guess. Or should we do the hard one? No, I don't think you'll ever have one this hard. So, oh gosh. I don't think you'll ever have one quite this hard, so we're not going to do 9. We'll do, come on, 8. What are we doing? Hold on. Let me see if there's any other examples. I think those both have no remainder, and I really want to do one with a remainder. Yeah, so we'll do 8. Same exact process. Create our division house. 6x cubed. Now it's good to recognize here, it's good to know that if it had skipped over a term, so say it had gone from x cubed, and pretend this isn't there, don't cross that out. We're going to use it in our problem, but pretend it's not there. And it goes right down to 12x, skipping over the x squared term, you're going to want to put a placeholder here in your problem. So don't write this what I'm writing in orange, but you would want to put 0x squared here in your problem as a placeholder. If your problem skipped over a term, you need a placeholder. But our problem didn't skip over a term, so I'm not going to put 0x squared. I'm going to put negative 13x squared plus 12x plus 6. And then we're dividing by 3x minus 2. And we start off by asking ourselves, what do I multiply 3x by to get 6x cubed? Yes, 2x squared times 3x will give us 6x cubed. And because I multiplied the first term, I must also multiply the second term. 2x squared times negative 2 is a negative 4x squared. And I need to subtract everything. 6x cubed minus 6x cubed is 0. 13x squared minus negative 4x squared is actually plus 4x squared, which gives us a negative 9x squared. Then I bring down my next term. We'll do green. And I asked myself, what do I multiply 3x by to get negative 9x squared? Positive? Right, negative 3x. Good. And then I multiply negative 3x times 3x and I get negative 9x. These should match, and they do. Negative 3x times negative 2 is a positive 6x. And then I need to subtract everything. Negative 9x squared minus negative 9x squared is actually a plus 9x squared, so they cancel. And 12x minus 6x gives us 6x. And then I bring down my last term. And I repeat. I ask myself, what do I multiply 3x by to get to get 6x? 2. Just a 2, a plus 2. Multiply 3x times 2 and you get 6x. Multiply 2 times negative 2 and you get negative 4. Then we subtract everything. 6x minus 6x is 0. 6 minus negative 4 is actually 6 plus 4, which is 10. There's nothing else to bring down, so this is my remainder. So our problem's answer, our problem's dividends, starts off as the top, 2x squared minus 3x plus 2. Does anyone know how I would write the remainder? I know that you've been taught, or I think that you've been taught multiple ways to write the remainder in the past. In higher level math, we never write the remainder with an R or anything like that. We write it as a fraction, as a number. How do you write the remainder as a fraction? We know our remainder is 10. Technically, what's still happening to that 10 that we couldn't do? It wouldn't fit into 10, but it still is actually an operation being performed on the 10. Ah, it's being divided by what? What is doing the dividing in this whole problem? Yes, 3x minus 2. So our 10 is being divided by 3x minus 2. That's how we write the remainder. And we're done. And we do put a plus between because otherwise it'd be 2 times 10, and we don't want that. Any questions on this problem? Do you want another long division example? Is the question. Okay, we can do another one. Let's do this one. Let's do this one because we haven't done an x squared yet. So we go ahead and create our division house. There aren't any terms I'm skipping over, so I don't have to worry about any placeholders. But it is large. It is quite large. It is one term larger than the ones we've been doing, but it's still the same process. We're fine. We know how to do this. So, how many times does x squared go into x to the 4th power? What do we multiply x squared by to get x to the 4th? X squared, good. Multiply it back into both terms. We get x to the 4th. Now I am going to make sure that I'm lining up like terms here. Very important. X squared times 8 is 8x squared. So it's lined up with the x squared terms. And I'm subtracting everything. So here I have x to the 4th minus x to the 4th is 0. The x cubed term has nothing to combine with, so I just bring it down. And 4x squared minus 8x squared is a negative 4x squared. And bring down your next term. What do you multiply x squared by to get 3x cubed? 3x, good. Multiply the 3x back in. 3x times x squared is 3x cubed. Good, they match. I'm doing it right. 3x times 8 is 24x. I'm not going to line it up with the x squared term. I'm going to line it up with the plain x term. So that's 24x. And I'm going to subtract everything. 3x cubed minus 3x cubed cancels to 0. There's a 0 placeholder here for the x squared, so I'm just going to bring down the negative 4x squared. And 24x minus 24x leaves us with 0. And you bring down the next term, negative 32. What do you multiply x squared by to get negative 4x squared? Negative 4. Then you multiply the negative 4 back in. Negative 4 times x squared is negative 4x squared. They should match, and they do. And negative 4 times 8 is negative 32. This is the x term. I guess I should have put this. I'm going to line it up with my constant. And I subtract everything. Negative 4x squared minus negative 4x squared is actually plus 4x squared, so it cancels. And negative 32 minus negative 32 is actually plus 32. It also cancels, leaving us with no remainder. So my answer here is, why won't it zoom out? There we go. My answer here is just x squared plus 3x minus 4. And again, this should make sense because I started with an x to the fourth. I'm dividing out an x squared, so my answer should be an x squared, which it is. Any questions on this one? Notice some of these have a remainder and some of them don't. What do you think it means about the ones that don't have a remainder? If I'm looking here, what does it mean about this in comparison to what was being divided, the polynomial? What does it mean about x squared plus 8? If there's no remainder, then the divisor, that's the term dividing, then the divisor is a yes, factor. It is a factor. If it divides evenly, it means that it is a factor of the polynomial. So here, x squared plus 8 is a factor of that polynomial, x to the fourth power plus 3x cubed plus 4x squared plus 24x minus 32. Here, 2x plus 7 is a factor of that cubic function. Here, 3x minus 2 is not a factor because there is a remainder. So 3x minus 2 is not a factor of that cubic function. That's what dividing tells you. Tells you whether or not there's a factor, or it is a factor. Okay, notice here, I skipped over the problems that are just a plain x with a number. Why do you think I did that? Do you remember from Algebra 2? I know it was so far, it was so long ago. Nobody? Okay, fine. I skipped over these because there is another easier way to divide. Unfortunately, the reason why I had to show you long division is because this easier method does not always work. It does not work on x squared, so you can't divide by x squared using this synthetic division. And you also cannot divide using synthetic when there is a coefficient on your x. You can only use this easier method, synthetic division, when you have just a single x with a number. So here on 3 and 4, I could have used synthetic, so that's why I skipped over them. I skipped over 7 because I could use synthetic. I didn't do 9 because you won't have to do anything that hard. And now I also didn't do 10 and 11 because, again, you can use synthetic. It's just a plain x with a number. So let's go ahead and try to recall synthetic. That's this down here. Let's go ahead. We'll do number 12, yeah. Now, the trick to synthetic, or one of the tricky parts, the reason why students get synthetic division wrong is because they miss what you're actually dividing by. When you're using synthetic, you're actually dividing by the zero or the root, not the factor. So they're always going to give you the factor. They're always going to give you this binomial. But when you're using synthetic, you need to find, or you need to know, the zero for this factor. What is the solution for the factor x plus 4? Where is that zero located? Where is that root? Yes. Remember, to get the zeros or the solutions or the roots, there's so many names for it, the x-intercept, you set the factor equal to 0, and you get the x by itself by subtracting over. So here, x equals -4 is our 0. That's actually what we're dividing by, -4, not the +4 that the problem originally told us, just the -4. So now, first step in synthetic is to create a double-story upside-down division house. Like this. It's got 2 rows in it. It's doubly tall. And inside the top row of the division house, you're putting the coefficients on your polynomial, on what is being divided. So here, my coefficient on x cubed is a 1. My coefficient on x squared is a -1. My coefficient on x is a -27. And my coefficient, well, it's a constant, so I just place the entire constant. Then, on the outside of my division house, I place what I'm dividing by, which is that -4. Your first step when dividing by synthetic is to bring down this first term, 1. Just bring it down. Bring it right down. Then we're multiplying. So we're going to multiply what we're dividing by, -4, by what we just brought down, 1. So -4 times 1. I'll even write it here. Multiply. -4 times 1 is -4. And you place it inside the division house in the next slot. And then you are adding inside of your division house. You're adding. So -1 plus -4 is a -5. And then you just have to repeat. I guess I should do different colors. -4 times -5 is 20. and then you add them together. Negative 27 plus 20 is negative 7. And then you multiply. Negative 4 times negative 7, and you get a positive 28. And then you add negative 28 plus 28, and you get 0. The last number is always your remainder. Because our remainder here is 0, it means we really don't have a remainder. And because my original leading term was an x cubed, and I was dividing out a single x, what should our leading term's x be? What type of x? I'm taking an x cubed and dividing an x out. So what should my leading term's x be? Yes, x squared. Good. I'm going from an x cubed, dividing out an x. I should be left with an x squared. So that means my leading term should have an x squared. And what you do is on that leading term, you place the first number you found, 1. Then my next x is just a plain x, and I place the next number I found, negative 5. And then my next term should be a constant. I just bring down my last number. This is my answer because there was no remainder. And I'm done. If you don't like figuring out what the leading term's x should be, what you can do is you can work backwards. You know that the last number is always your remainder. The number in front of it should be your constant. The number in front of that should be your plain x. The number in front of that should be your x squared, and so on. You can do it that way as well. I just like thinking of it as, okay, I take an x cubed, divide out an x, there should just be an x squared left. All right, let's do another one. So here, my factor is x minus 2. Oh, shoot. All right, so my factor is x minus 2. I'm actually dividing by the 0, which I add the 2 over. X equals 2 is my solution, or 0, or root. I create my double-story upside-down division house, and I place my coefficients, 3, negative 22, 37, and negative 10. And I'm dividing by 2. First step, bring down, oh, I said green. Okay, bring down the first term, 3, and then you're multiplying. 2 times 3 and you get 6, and you're placing that inside your division house in the next slot. And then you do negative 22 plus 6, and you get negative 14. Nope. Nope, nope, nope. Negative 16. And then you do 2 times negative 16, and you get negative 32. And then you add 37 plus negative 32, and you get 5. And you multiply 2 times 5, and you get 10. And then you add negative 10 plus 10, and you get 0, which is your remainder again. Our next number in front of the remainder is always your constant. The number in front of that is your plain x. And the number in front of that is your x squared. So that's our answer, and we're done. It's much less writing. Much less writing than long division. But again, you can only use it on single x's with a number. You can't use it when there's a coefficient on the x. You can't use it when it's x squared or anything larger than a plain x. Let me do one more, because there are ones where it's skipping terms. So let's look here at number 16, and then we'll call it done. If you're comfortable with synthetic after this problem. So here we're dividing by not 8, but the 0, negative 8. Right? We just set that equal to 0, subtract 8 over. So I create my division house, and I'm dividing by negative 8. My first term's coefficient is 1. Now notice here, it is skipping over the x squared term. It goes from x cubed to the plane x. There is a missing term here. Whenever you skip a term, you must put a placeholder in division house. So because I'm skipping from x cubed to x, I need to place a placeholder of 0 for the x squared term. Then my next coefficient is a negative 49, and then I have my constant 120. So now, just like these, now it's exactly like it was before. I bring down my first number, 1. I multiply negative 8 times 1, and I get negative 8. I add inside my division house. 0 plus negative 8 is negative 8. And I multiply negative 8 times negative 8, and I get 16. Oh, God. 64. Miss Sunderland. And then I add negative 49 plus 64. So what is that? 15. And then I multiply negative 8 times 15. So 8 times 10 is 80. 8 times 5 is 40. So that's 140. 120. My God. What is wrong with me today? And that's a negative 120. So I do 120 minus 120, and I get 0. So my term in front of my remainder is always my constant. Then the term in front of that is my x. The term in front of that is my x squared. And I'm done. If there had been a remainder, so say this remainder had been 8, say. Just like we did with long division, it would have been, now don't write what I'm about to write in red, because it's not right. But just like I did with long division, we would have written 8 over the factor I'm dividing by, x plus 8. But I didn't have a remainder, so I don't worry about that. And this is my answer. Are there any questions? Would you like to see another one?